Waste.
That means our approach is Six Sigma whenever we focus on reducing the defects. Not just reducing the defects, we are also trying to prevent the defects in the future. Then the project should be known as Six Sigma project. If your primary focus is on waste, then the project should be called as Lean
Lean.
project.
Lean Six Sigma.
So Six Sigma project will enhance your process effectiveness. A lean project will improve the process efficiency, right? So any form of ineffectiveness will lead to defects, and any form of inefficiency will lead to waste. So
Waste.
we wanted to make sure the effectiveness as well as the efficiency are improved simultaneously. And that's why we integrate lean as well as the Six Sigma principles, and we focus on eliminating both the defects as well as the waste so that our quality improves. At the same time, our profitability also improves, leading to customer satisfaction as well as employee motivation. It's a win-win, growth, win-win scenario for everyone. And then in Six Sigma or Lean, what is very, very important is process improvement. We understood y equal to f of x, right? Y is the output, x are the input. Any problem with the output, we try to correct it by correcting the input, right? It can be just one input or it can be sometimes a combination of several input. So we, in order to validate the critical factor, in order to make the right correction, we even go to the extent of using the statistical tools and techniques, right? Our analysis can be qualitative also, our analysis can be quantitative also. It depends on the nature of the problem, right? If the problem becomes complex, obviously we need to be data driven. We'll focus on using the statistical tools also. And also, we understood that the Six Sigma methodologies, DMAIC, define, measure, analyze, improve, and control. We always go through, we always go through all these five stages in the same order. Because we very well know that if we jump to the solution straight away without worrying about the define, measure, and analyze, we may not be always correct. If you want to be always correct, if you want every single project to deliver the result, then it will be a great idea going through the DMAX cycle, right? In define phase, our idea is problem understanding. In measure phase, our objective is measuring the baseline. In fact, today we are going to start with the measure phase. So baseline in the sense, we want to understand the ground reality. We want to understand the intensity of the problem. Once that is known, the target is already fixed in the define phase. So the gap in the performance can be correctly understood. Here, accuracy is our major concern. We just don't want to go with the assumption. Rather, we would like to have a accurate understanding of the baseline and the gap in performance. Then we move on to analyze phase. In analyze phase, our objective is to understand the root cause, not just the symptoms. So we identify root cause, we validate root cause, and then we try to understand the relationship between root cause and our pain metric, which is the Y variable. We call it the project Y. The project Y and the X factors. What is the relation? Is it positive or negative? Is it linear or non-linear? And to what extent the relationship is? We call it contribution, right? So, or the influence, how much influence each factor has got. Accordingly, we will use this information in the next phase. The next phase is improve, solution generation. So solution generation is correcting the X. How can I correct the X? Can I make changes in the existing system? Or should I go for something new, add on to the existing system? So ultimately, our goal is we want to change the X factor in the right direction. This is what we call it solution. Once the X factors are corrected or X factors are changed, automatically our project Y will improve. Our project Y will improve. So, which means, we have solved the problem. And now you can again collect some data and you can get it validated whether you have we really solved the problem, right? And so you can collect the data and then try to understand. This is called solution validation. And then we move on to the control phase, where we take measures to ensure that the X factors no more affect our Y factor, so that we will continuously monitor certain X factor, continuously control those X factor, because all of them were critical factors. All of them were the root causes when we actually studied. So we will develop a control plan to monitor and control certain X factor. Thereby, the same problem will be prevented. This is what is the DMAX cycle is. In defined phase, we studied a lot of tools, and some of them are even ahead of the yellow belt requirement. We studied voice of the customer, voice of the business. We studied about CTQ and CTQ tree. CTQ stands for critical to quality. We also studied about CTB, critical to business, which is derived from the voice of the business. We also studied cost of poor quality, internal failure cost, and external failure cost. And we also understood how we can use brainstorming to identify problems or to bring the problems to the surface, right? So these are all problem identification tool, the very first step. Though yellow bells are not responsible for the first step, but still it will be helpful. So the first step is problem identification. And the project sponsor, champion, they are majorly responsible for problem identification. And then the project team will be working on. Then the second step is problem understanding and selection. Problem understanding and selection. For that, we are used Pareto. We used Pareto. We plotted even subdivision Pareto. From one specific information, we drill down to a more specific information. We call it stratification or subdivision, and ultimately we are able to deep dive into the problem. Right? The problem is thoroughly understood. The scope is also understood, and then we moved on to project charter. In project charter, there are 6 major elements: business case, problem statement, goal statement, scope statement, timeline, team member, and then it is signed by project leader, finance controller, and then project sponsor. Right. So we have studied all of this, and now the project charter is approved by the sponsor. So now we are in the measure phase. In measure phase, our goal is to, as we already
Smart
mentioned,
goal.
yeah, baseline. So
Mm.
in measure phase, our goal is to measure the baseline or the intensity of the problem. We need accuracy in our finding. So for that, we'll go through the similar three steps using certain tools and techniques, and that is what we are going to learn before the tea break. So hope all of you have gone through the materials also, as well as the recording also. Hope you had a good understanding of whatever you have discussed so far. If there are any questions you would like to ask, feel free to ask. I'll be happy to clarify, and then I'll be taking you through the measure phase steps and the tools. Any question, anybody you have? Feel free to ask. I'm just getting my slides meanwhile. Module 2. So tomorrow we'll be finishing off the yellow belt modules completely. We'll also try to see a sample project. So no questions. That means we are good to proceed.
Yes, sir.
Okay. Okay. So since you people don't have any question, I have few questions to ask. All right. Can one of you tell me what is the difference between voice of customer and voice of business? What is the difference between voice of customer and voice of business? Are they
Yeah,
same or are they different?
so both are different,
It's
sir. Like
different.
voice of
Both are
customer
different.
is feedback which we get from external source, that is the customer, whereas voice of business is the internal feedback which we get from the employees.
Oh. Do you think employees' voice or voice of business, or their voice can be in Six Sigma, or their voice can be called as voice of internal customer? Because there is also a terminology, external customer and internal customer. So all internal customers are not, you know, may not represent the voice of the business, right? So employees, when you say employees, it is voice of internal customer. When you say managers, leaders, management, then only it is voice of business.
Business.
Or mathematically, if you are talking about why, it is customer voice, right? In addition to why, the voice of the business will also talk about Z. What are Z? The Z variable. The business results, right? So voice of managers, voice of leaders. So don't say employees, the managers and leaders, their voices VOB. Got it, Mr. Likith?
Yes, sir,
Understood?
it's clear. Yes.
Yeah.
Thank you.
Sir,
So that's one thing.
in one line, what is voice of business? I can say
Come again?
in one line. How I say the voice of business? POV.
Management's voice.
Okay, okay, sir.
All right. So voice of
And
business. And similarly, cost of poor quality can be internal or external, right? So what is the difference between internal failure and external failure? Are they same or different? Different.
different.
So what is internal failure and external failure, and how are they different? If the fail,
Internal failure is when the defect is found before the product is released into the market.
very good.
So
Very good.
then external failure is when the product is released into the market and we get back the feedback from the customers.
Very good. Product or service. If the failure is detected externally or detected outside your organization, it's external failure. If you could detect internally within your organization, then it is internal. Very good. And what is the difference between problem statement and business case? What's the difference between problem statement and the business case? Are they same or different? They're not same, right? They are different. So what is the difference?
A problem statement is the document which shows the what is the exact problem and the team is trying to figure out, and the business case which represent what we are up to do or what kind of business we are trying to procure.
You can use simple language, right? A problem statement talks about the pain being experienced by the customer or the business, right? But at the same time, business case talks about the business results or the business consequences that may arise based on the success or failure of the project. So, or otherwise, still further simple, you can say financial benefit straight away. Business case means financial benefit. Also, you can add non-financial benefit. If you're talking about the financial benefit or non-financial benefit, then you're actually describing the business case. Hope all of you are able to differentiate, right?
Yes, sir.
Yeah. So financial benefits, financial loss is different from the actual problem we are trying to solve. In order to understand the actual problem only, we use a tool which is known as CTQ or CTB. Am I correct?
Yes,
Yes.
sir.
If you solve the problem with respect to the CTQ, then your business result will improve. So when you are writing the business case, please restrict your wordings only to talk about the business result. While writing the problem statement, please restrict your words only to talk about the problem being solved. Right? You talk only about the CTQ. Nothing but CTQ or the Y. Business results are the Z. All right. So now let me share my slides. Hope all of you can see my slides.
Yes, sir.
So, introduction to the measure phase. Tollgate review, steps and the deliverable, and then the tools. So again, in the measure phase, your understanding on the CTQ must become very, very clear. So you should have a clarity on the CTQ. Clarity in the sense, you should even be able to tell you what will be the unit of measurement. What will be the unit of measurement for your CTQ, right? And then data collection plan. You should have an appropriate data collection plan. And you should have a sound measurement system. A measurement system that is capable as well as adequate enough to cover your data range, right? Whether the values are small or big, your measurement system will always give error-free reading. And then any data, the worthiness of the data. So the data must be appropriate for the analysis. And then finally, how far is the project goal from the current performance? Your current performance is baseline. Your target is the goal. So the difference is the gap. So these are the questions you should be able to answer at the end of the measure phase. And definitely any tollgate review, people will talk about these questions. So the first step, data collection plan. And then validating the measurement system. And then measuring the baseline. We actually collect data. Please note, here only we collect data. In step number 6 only we collect data. And then we calculate the baseline. Ultimate deliverable is baseline performance. The ultimate deliverable in the defined phase is approved project charter. Same manner, the deliverable in the measure phase is baseline. And here are the tools. And some of them we are going to master as part of this yellow belt program. Operational definition, data type, and then bias, repeatability, reproducibility, gauge R&R, traditional yield, first pass yield, rolled throughput yield, DPMO, and then CP and CPK. DPMO, we already had an exercise, right? We remember, we already measured it. So these are the tools. So we'll speak about them one by one. So step number 4 is data collection plan. So how much time is available for us for the data collection? Do you think you will always get an answer for this question? How much
No, sir.
time is available for data collection? Yes or no? For
No,
example,
sir, it depends.
No, sir.
for this yellow belt training program, how much time I have to understand about all of you? Do you think there is an answer available?
No, sir.
Why? No.
Unless
Right?
and until we don't give exam, you will not come to know who understood and who did not.
I am not asking about data. I am only saying about time. Is the timeline is aware known? The start date?
Yes, yes.
Yes, sir. 4 days.
So
Good.
you
Four
must
days.
try to understand that first. Right? How much time is there for you to collect data? If data is already available, That's fine. You can use it. But even then, it is always good to have your own data because it will be very authentic, isn't it? Because you are directly collecting. All right. Because sometimes what happens, the past data, may not be reliable, but you can use it as a reference. So the time that is available for data collection, sometimes it is 1 week, sometimes it is 1 month. It depends, right? So once that, but how can you be more efficient? How can you be more accurate within that available period? That's why we have a data collection plan. I'm not talking about amount of data or anything. No, I'm only saying about the time duration that is available for data collection. All right. Let's say there is an audit. There is an audit coming next week. That means we only have 1 week right now, isn't it? Anything we want to do, we should be able to do it within this 1 week. Or anything already available, that's fine. But if only 1 week is available, and if you decide, okay, I will wait for 6 months data, then you're not understanding, the requirement. So always try to understand the time duration that is available for you to collect data. Then you can devise a very good data collection plan. If you have 7 days of time, would you like to collect data on all the 7 days? That's a great idea, isn't it?
Yes, sir.
You got only 7 days. So let us collect data on all 7 days. Because always the amount of data, the more is better. Amount of data is, the more is better. So all 7 days, all 3 shifts, and every shift, do you want to collect data once in an hour, or once in 2 hours, or once in 3 hours? Just think about it, your common sense, right? If you have a proper understanding of the problem, if you really wanted to understand the intensity of the problem, you will certainly have answers for these questions. What is the time available for me to collect data? And at what frequency I should collect data. But ultimately the goal is the more is better. The more is better. And again, when I actually go for data, let's say every 1 hour I decided to collect data. If I decide to collect data every 1 hour, imagine how many times I should take samples in a day. Every 1 hour
24 times.
or 24 times. Right? Every 1 hour means there are 24 hours. So 24 times. So 24 into 7 is how much? Nowadays, we can't even do simple max. We are so addicted to these gadgets, apps. So 24 bar 7, 100 and
168.
168 data points will be there. Am I right? 168. Do you think this much data can definitely throw light to understand the problem? Yes or no?
Yes.
Yeah. So this is called a data collection plan. This is called data collection plan. So we'll understand that. So in order to understand the data collection plan, again, we have certain, requirement. You should have a crystal clear clarity on what, what to measure. When I say what to measure, I actually mean the CTQ. Am I right? You ask yourself one more time, the CTQ, is it really reflecting the problem? Let's say you have a health issue. Will you focus on looking at the right metric that is responsible for the health issue? Or are you okay with seeing any number? Tell me.
No, a
If there is,
proper number.
yeah, you will definitely consult 2, 3 doctors. Sir, this doctor is telling, my hemoglobin level is very low. Something. Or cholesterol is very high, or my BMI is not proper, or my sugar level is not proper, or my pulse rate is not proper. Now, out of all these number, which is a real indicator of the problem? Somebody will say, hey, pulse rate, don't worry. It will fluctuate like this only. You don't have to worry. Somebody might say your BP level, yes, it will be in this range only. No need to worry. But probably no,
Yes. Yes.
some other metric. Oh, this is really, cannot be this much big. That means this is the real indicator. So likewise, when you are trying to solve a problem, you should be able to settle on a metric or a single metric that can be a representative of the whole problem. That can be a representative of the whole problem. Say, for example, here we try to understand whether you are undergoing the required transformation to be certified as an yellow belt, isn't it? So we want.
Yes.
So are we looking at some data here to understand this? Are we really worried about your age? No. Are we worried about your color? No.
No.
These data, no, are not representing, your level of transformation. So we decided to look at your marks,
What to
isn't it?
measure?
Test mark. But I can
Mm.
always improvise this CTQ. I can always improvise, isn't it? Because people find ways, they always get the shortcut, isn't it? Whatever be the, metric we set, they always find a shortcut. So we can tighten this to ensure our metric is a real representative of the problem, right? For example, we can find out a weighted number which considers your test mark, which considers your attendance, which considers your participation and interaction, which also considers your assignment and things like that. Now, how many factors? Four factors I told. If I use all these four information and find out a single number, which I call it as a weighted number, will it be a good indicator?
Yes.
That's how your CTQ should be, right? So you don't have to just go with what is available. You can even create it whenever needed, right? So that's the first step. And then you try to collect data relevant to your CTQ. If I decide to go with a weighted number, then I should not only wait for your test mark, I will also wait for your attendance. I will also wait for your, what do you call, the interaction, level of interaction. Every session, level of interaction will be marked for every student. Today,
Mm.
interaction very high. Some students very low. I will also refer your, performance in the assignments. That will be beautiful, isn't it? So your data collection plan. So the understanding on what we actually really want to understand, that is driving us now. And then data type on operational definition. Your attendance I can measure accurately. Am I right? Your attendance I
Yes.
can measure accurately. Similarly, your assignment level, but your interaction level, it has to be subjective based on your interaction, low, medium, high. So in some manner, I will be collecting data. Some of them will be very accurate and some of them will be less accurate. So
Approximate.
yeah. So less accurate data is one category and the more accurate data is another category. We are going to understand all of that. And then for each and everything, there has to be a clear operational definition given. When I say attendance, I should actually give a definition. What do I mean by attendance, isn't it? What
Mm.
do I mean by attendance? Attendance means you should be present in the meeting
Present.
at least for 80% of the time.
Mm.
Good definition?
Yeah.
Good definition or not? Or do you
Yes.
only want to give appear for the pose? Now, whenever we take a photograph, you only want to appear for the pose and then run away, or do you want to be present in at least for 80% of the training session, which is a good operational definition. The second
The
one.
80% one.
Yeah. So what's very, very important is we should make people understand all of this. Each one of you should come to a common understanding. If one person understand in a particular way and one person understand in other way, we are not going to produce yellow bells for the country. We are going to only print certificates. Printing certificate is a different approach, altogether a different idea. But we are here not to print certificate. We are here produce yellow badge
Knowledge.
who can serve the society, isn't it? So operational definition is very, very important. So the same thing is expected from you also when you are doing a project. When somebody is asking you, what are you measuring? You should be able to, give them a clear-cut idea. Hey, this is what I'm trying to measure. So this kind of data is required. Then only I can understand this. Likewise, you must have. And that's called operational definition. So all of this we are going to understand right now. Now, CTQ means what? CTQ stands for critical to quality characteristics.
Quality.
These are the key measurable characteristics of a product or a service whose performance standards or the specification limits must be met in order to satisfy the customer. If this is not happening, then definitely that will cause pain. That will definitely lead to customers' dissatisfaction. So, for every CTQ, customer has got a clear target. And customer has got an upper limit as well as a lower limit. And you should be able to understand that. Customer has got a target, upper limit, and the lower limit, isn't it? So, what kind of target you have right now in the yellow belt exam? I understand, right? So, 60, we say 60% is the pass mark. But as a customer, you might definitely have some idea. Yeah, let me go with at least 80. That means your range is 80 to 100, right? So something like that. So it can be the property of a particular physical product, or it can be the characteristics of the service. Say for example, you are buying a loan. Now interest rate is the CTQ. Customer has definitely has got a target. If I go for a personal loan, then the interest must be lesser than let's say 14% diminishing rate. Now this is CTQ. So the maximum interest rate tolerable is how much? 14%. And if you are a bank offering loan, then you must understand this. And if you understand and then offer a particular product in that category, definitely many people will buy your loan. Okay. Now data type. As I already mentioned, data type can be two. Data type can be on any one of the two category. One is continuous data, another one is discrete data. Continuous means the accurate data. Discrete means less accurate. Because in discrete data, you only understand the category, not the exact value. Understanding the category is different. Understanding the exact value is different. If I ask you what is your room temperature, and what will you say? Sir, room temperature is very cold now. Now you are understanding the category of the temperature, or are you getting the accurate value of the temperature?
Accurate value.
Category.
Category. You are saying only, no, sir, the temperature is cold because it's raining outside. So it's cold. So it's a category. It's very cold. It's very, hot, or it is moderate. These are all categorical data. But if I take a thermometer and then measure the room temperature and tell you the room temperature is 27.3 degrees Celsius. Now this is accurate. Do you get my point? This is called continuous data. So which is better?
Yes, sir.
Continuous data is better, right? Continuous data is better. Wherever possible, try to collect data in continuous fashion. We'll understand both of them here. All right. So continuous data is a quantitative data that can be measured. It has infinite number of possible values within a selected range. Can one of you explain the meaning of this statement? It has infinite, what is written? Infinite number of possible values. Can you tell me what is this? What does it mean?
I mean, in a scale of temperature, it could be anything within that range.
Very good. You are expecting always, room temperature means, let's say it will be between, you know, you very well know it will be from 20 degree to 35 degrees Celsius. But from 20 to 35, how many values are possible? You can't just count, isn't it? You can't count and you can't predict also. Anything can come. If you take a thermometer, it can be, any one of the infinite possible values. All of you understand the meaning of infinity coming there?
Yes.
Yes, sir.
That's why it's called continuous
No,
state.
sir.
That's why it's called continuous state. Suppose if I give you a form where you have to fill up, how do you like the training session? And there are options given. I'm very satisfied. Another thing is, I'm satisfied. Another one is, I am dissatisfied. There are only three options. You can either say you are dissatisfied, or you can say you are just satisfied, or you can say you are highly satisfied.
Not satisfied.
Now, how many possibilities are there? Only three. Finite possibilities. Your data can be in the finite possible category, or your data can be in the infinite possible category. If it is in the finite possible category, we call it discrete data. Now, can one of you read the definition for discrete data? One of you, can you read?
Discrete data is quantitative data that can be counted. For example, the number of a student in a class.
So, it is defined slightly in another way. Countable data, right? Countable data. Like how many people say satisfied? How many people said dissatisfied? After completing the survey, what will you do? You would like to understand how many is dissatisfied, how many satisfied, how many are highly satisfied. That means your data is countable data. Only by counting you interpret. Such data are known as discrete data. Now, if I ask you, how many people are on the video now, right now? How many people are on the
38.
video? 5 people, huh?
38.
5 people, right? It's like Pareto, 80-20.
Okay.
80-20 rule. Out of 40, okay, not even 80-20. Okay. So this is a countable data. Right? You just counted. How do you know there are 5? 1, 2, 3, 4, 5. Whenever you count, your data is discrete data. How many customer complaints? That's a discrete data. How many items rejected? That's a discrete data. How many times transaction failed? That's a discrete data. So you should know what kind of data you are dealing. This will be helpful later during analysis. This will be helpful later during analysis. Because when you want to use a tool, you should know the purpose of the tool and the platform where you are going to use the tool, isn't it? If your job is carpentry, then you have a set of tools. If your job is plumbing, you have different set of tools, isn't it? Same manner, if your data type is continuous, you have a set of tools. If your data type is discrete, you have another set of tools. If I interchange the tools and still try to do the work, do you think I'll end up bringing the perfect finish? Difficult.
No.
You might think tools are almost same. Then you can't interchange the tools. Same manner, during the analysis phase, this information will be very, very helpful. So data can be, divided in this manner. First classification, qualitative data. Another one is quantitative data. Any information that you collect without using numbers, that is known as qualitative data. I collect all your native places, and that was beautifully typed in an Excel file. What is this data? Qualitative data or quantitative data?
Qualitative.
Qualitative data. There are no numbers. Mumbai, Pune, Delhi, Hyderabad. This is qualitative data. Your name, qualitative data. Right? There are many things, qualitative data. But I collect your age. That's a quantitative data, isn't it? I collect your age, that's a quantitative data. Your height, your weight. So basically, you understand the difference between qualitative data and quantitative data. What is the advantage with quantitative data? Can somebody tell me?
How much quantity of the people are there?
Very good. How much quantity you can understand. Mathematical operations are possible.
Yes.
Addition, subtraction, multiplication, division. These are the four things we are interested in. We have studied. But if you have the qualitative data, you can't do anything, isn't it? Can I add Sushant Patil plus our Majumdar is equal to Srinivasan Mani? I cannot say like that. Right? That's not
No.
possible. So the name is helping us only to differentiate. That's all. There ends the matter. So that's the disadvantage with qualitative data. You can use it to differentiate. But quantitative data, you can even perform mathematical operation. Again, in the quantitative data, we have two types. One is continuous, another one is discrete.
Hmm.
Discrete is otherwise known as attribute data, also known as categorical data. Only the names are different. One is continuous, another one is discrete.
Discrete.
What are the other names for discrete? Attribute,
Attribute.
categorical data. Now mathematical
Countable data as well.
operations. Now mathematical operations, there will be a limitation with your categorical data. Right? There will be a limitation, your categorical data. But continuous data, there are no limitations. It will be more accurate and you can perform all mathematical operations. You can add, subtract, you can multiply, divide. But here, only certain operations are possible. Say, for example, I give rank. I am ranking all of you, right? First rank, second rank, and third rank. And now if I ask you what is the difference between first rank and fifth rank, will you be able to tell me? I am only giving you the rank, isn't it? 1, 2, 3. So the rank is only ordinal. The rank is only ordinal, isn't it?
Hmm.
Right.
Only
Yes,
the
sir.
Yes.
order only the order I can understand. Only certain information is available, not the complete information. But if it is a measurable, let's say one item is having a weight of 100 kg, the another item is having a weight of 84 kg. Now the difference is 16 kg, isn't it? And
Yes.
the both items together, that will be 184.
184.
Yes or no?
84. Right.
Yes.
So addition is also possible, subtraction is also possible. One item is 50 kg, the other item is 100 kg. That means the one item is double the weight of the other item. So you can interpret the information with all mathematical operations. So you should know the plus and minus of your data while doing the analysis. So the gold mine is continuous data. Always try to measure. Don't just settle with the categorical data. People say, how is the customer service? Customer service is excellent. When they say customer service excellent, and that's a categorical data, isn't it? So
Yes.
try to convert everything into number, and that number should be a measured number, then a counted number. All right, so that you can gain a crystal clear information about what you want to understand.
Okay.
Hope all of you understand now the difference between continuous data and discrete data.
Sir,
Correct?
I had a doubt. So
Yes.
when you say ki, the customer service was excellent, shouldn't that
Ah.
be considered as a qualitative data instead of
Yes,
discrete?
it is qualitative data. Excellent is qualitative data. And
Qualitative.
then you will do something to convert that into a number. Excellent means 5,
Hmm. Hmm.
right?
Yeah, that's
And
right.
poor means 1.
0.
1, 2, 3, 4, 5. You got any one of the 5. Now it is discrete. So
Yeah, got it.
always we tend to convert data from qualitative to quantitative. And then the quantitative also, if you are using discrete data, at some point of time you will realize you would have measured it much more and a little more accurately. And then you will revert to continuous data.
Hmm.
So straight away having continuous data is more advantageous. But but sometimes whenever the need arises, you can immediately switch to the better format. Clear?
Yes, sir. Thank you.
Okay. So now let's do a small exercise. All of you can now participate. You are going to categorize the list of CTQs, I would say. All these CTQs, are they continuous data or discrete data with your current understanding? Now tell me, turnaround time. Is it continuous data or discrete data?
Continuous data.
Continuous data.
Continuous.
Because you can measure it.
Yes.
Hmm.
When you
Hmm.
not only you measure it, you also have a unit of measurement. You also have a unit of measurement. What kind of unit you can use for time?
Minute, second,
Second, minute,
Measure-
hours.
Hours.
Okay. Then which is better? Minutes is better, seconds is better.
minutes.
Second.
Again, it depends, on the
It
problem.
depends.
Yeah, it depends. If it is a 100-meter race, maybe you may go to the extent of microseconds, isn't it?
Yes.
Yes.
So people can finish 100 meters just like that. So it depends on the problem and the requirement. So very good. So turnaround time belongs to continuous data. Now next one, customer satisfaction score. Every day at the end of the training, you are giving the rating, isn't it, in the feedback form? So what is that?
Continuous.
Continuous.
So really,
Continuous. Discrete.
Discrete data.
continuous means
Number of
in
customers.
form you can type any value. 4.35 also you can give me.
Yeah.
If you like the
Real
training,
number of
if you like the training, you give 5. The next option is 4. In
four.
between 4 and 5, there is no option.
3.5. Okay.
3.5 is not available.
Okay. Okay.
So it is discrete. Only 5 values are possible. 1, 2, 3, 4, 5.
Okay.
You
Okay.
have to restrict. Yeah, then it is
Available.
number of failed transaction.
Discrete.
Discrete data.
Because that is also countable, right? Always whole number. Maturity amount.
How much?
Continuous.
You have invested,
Continuous.
some 5 crores in a bank. After 5 years, how much it will be? So that is
Countable data.
countable, right?
Discrete.
You always count currency.
Discrete.
So you are saying it is discrete.
Discrete data.
No. Count
It is
currency.
continuous.
It is continuous.
It depends on everybody's maturity
Yeah,
amount.
correct. A maturity amount can come in decimals and it has a unit of measurement, rupees.
Yes, sir.
So it is continuous. Total available balance.
Continuous.
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 I think there was a network issue on my side.
Yes. Yes.
Yeah, I will reshare my screen. Yeah. So time to resolve an issue.
Continuous.
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 Continuous. Number of credit cards that are linked to your savings account.
Discrete.
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 Time taken to process a loan application.
Continuous.
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 Number of clients served.
Discrete.
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 Now think about the data you deal in your current position in your company. You might be dealing with several data, isn't it? Day in and
Yes.
day out. Do you think you will now be able to categorize them correctly?
Yes.
Some of them are continuous, some of them are discrete.
Some of them are discrete.
Yeah. If you don't mind, can you give one example in the chat box, each one of you? The one you frequently discuss in the meetings and what it is. Is it a continuous one or a discrete one? Let all of us gain knowledge from each other here. Just type it in the chat box. Now we can by looking at the chat box, we can gain some knowledge from all the. No, you type, give an example and type, right? Don't just say continuous discrete. You give one example. For example, I will say, for me, what is very important is number of students. No, number of students in the batch. That is always a whole number. It's a I would say discrete. Okay. So number of defected bottles, discrete. And products sold today. Oh, product sold. Or number of units sold is discrete. But then if you measure the product sold, let's say sales value, then it is continuous. Number of customer complaints, discrete. How about others? Only very few are participating. Gaining knowledge is continuous. No. Knowledge, you can't say gaining knowledge is continuous, right? You should be able to measure it in a particular unit. That is difficult. Knowledge level. Knowledge level is always categorical, right? So, all right. So, number of packages. Okay. So, great. So, we just move on. So, when you are doing a project, and that time any help needed, please reach back. We can help you. All right. So, this is done. Okay. Unit of measurement, I think you have the, expertise to judge on the unit of measurement. When to go for minutes, when to go for seconds, when to go for microseconds, you know that. So unit of measurement is also important. But what is very, very important is if all of you work on a project, you all measuring a particular CTQ, then all of you must use the same unit of measurement. Yes or no?
Yes.
Yes, sir.
If I collect in centimeter and you are measuring, you are collecting in millimeter and someone else is collecting in kilometer and finally everything is available in Excel file without the, unit of measurement, then people will go mad by looking at your data, right? So that should not happen. We should never mix up data with the different type of units. All the data points should have the same unit of measurement and the appropriate one you should use. And
So,
then,
sir, for an example, likewise, you said that you cannot use a different this unit of measure. For an example, if I'm getting a delivery of a milk van,
okay.
okay,
Mm.
so I will be like collecting data like a degree of Celsius on which temperature he is giving me, another the
Oh,
liters, in how much
yes.
time. So,
All of them are continuous. Liters of milk, the
hmm,
temperature of the milk, or no, the travel time.
hmm,
These are all continuous. All right,
okay,
because all of them are measurable, right?
yes.
Now, when you tell anything, you should also be able to define it correctly. When you say liters of milk, so what do you mean by liters of milk? Is it the is it the volume of milk that is available in the container, or is it the volume of milk that is delivered at your end?
Delivered.
Yeah. So this such a definition should be available. Operational definition should be available. Otherwise, you know what happened? There will be a lot of confusion in the data. And all this confusion will lead to loss of accuracy of information. Am I correct?
Hmm,
So
yeah.
operational definition should be clear and understandable. Use simple English so that everybody can understand the same way. Isn't it? If it leads to three different meaning, then three people will measure in three different manner. We don't want that to happen, right? We want everybody to have the same understanding so that all of them will make the correct action, right? So that is the purpose of operational definition. That is the purpose of operational definition. Can you see some operational definition here? Sometimes, people use abbreviation. And during the project and during the discussion also, they use the abbreviation very frequently without even knowing whether the other person listening, know the meaning of it. So do you think they will understand and then talk to you the right way? No. If they don't know the meaning, then what will happen? Then they will simply, you will explain in a particular manner and they will understand in some other manner. That shouldn't be the case. So you keep your language simple in a way that everybody can understand. Particularly, our purpose here is the data collectors must understand, right? And now look here, the various order lead time, percentage late lunch hours, food preparation time, food cooking time, customer waiting time. This is the language used in a restaurant, restaurant. You can understand. Food industry. Now, what do you think is the meaning of order lead time?
And how much time you will get the delivery?
And
After
see,
order place.
yeah. Do you think this definition will be, common in all projects?
No.
It will be different. It can vary from restaurant to restaurant, project to project, case to case. Don't use the dictionary definition of any terminology. You have to write it. All the operational definitions should be included in your measure phase. All of you understand? In your project, when you are presenting your project, you can keep a document where the operation definition should be available for all the CTQs you are measuring, right? Similarly, preparation time and cooking time, are they same or different?
It's different.
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 Very good. So now, is it possible for you to spend 1 minute to think about a particular CTQ which you want to improve in your first improvement project? Suppose you want to do a project. What is the metric that you would like to improve? And also, can you write an operational definition for that metric? Is it possible in 1 minute or very difficult job? But let's do this exercise, right? Maybe you can take 2 minutes also. I am ready to give you 2 minutes also. Just think about it for 1 minute and then try to define it in another minute. And once you do it, and you can put it in the chat box or you can read out your definition. We would like to listen to you. Anything. If I say past percentage, then I should define what do I mean by past percentage. There should be a formula to calculate it. When I say the hardness of the material will be improved, then I should have a formula to measure the hardness. Something like that. Any characteristics that you want to improve in your first project, please write down a definition. Don't run away. Do this right now. Anybody ready with the operation definition? You're most welcome to share. You can just read out. Yeah. There is a operational definition available in the chat box. Likith, you are the right person to share. Please read it out.
So, sir, in my projects, the drawings that are created by my juniors will be reviewed by me. So, we consider it as a review time. So, basically, review time is time taken by me to review the drawings done by my subordinates.
Very good. Right? The starting point and ending point has to be clearly defined so that people can measure it, isn't it? Your goal is to reduce your review time. Am I right?
Yes, sir.
Yeah, very good. Number of tickets handled. Promit Sanyal, number of tickets handled. Is it hourly, number of tickets hourly or number of tickets daily or number of tickets monthly or number of tickets weekly? My question is genuine, right?
Yes, absolutely. It's number of tickets daily handled by the, maybe, there is a, team of engineers
Very
who are
good.
handling customer tickets.
Very
And
good.
on daily basis, it gets evaluated. And if some improvement needs to be done for the handling time of the tickets, then
Perfect. So the number of tickets handled, it's a voice of the customer or voice of the business?
it is the cost of the customer.
Yeah, internal customer. Very good. Very good. Correct. So water usage, meter cube of water per metric ton of production.
Production. Yes, sir.
Okay. At
So
first, yeah, you want to explain this? Yeah, Gaurav, please.
yeah, so we have a KPI like monthly almost 5 metric ton of 5 meter cube of water we are using for 1 metric ton of production. So I would like to improve this CTQ.
So for monthly, how many metric ton of production
So,
do?
so approximately it will be around 500 metric ton.
Okay.
So we will have similarly we will have meter cube of
Okay.
water consumption as well. So
Very good. Very good.
yeah, yeah,
So water consumption per metric ton of production you want to reduce.
yeah.
Simply saying, reducing water consumption may not make sense. Many times people don't understand that.
Yeah, yeah.
There has to be a denominator always. Salary is paid monthly, isn't it? If you simply agree salary of 5 lakhs and later on they say this is annual salary, then you will be in big trouble, right? So denominator is very important. Very good. So
Yes.
at first, check my projects team, make sure everyone is actively present and prepared. Suvajit Majumdar, what are you trying to say?
Now I am doing my MTech project in my college, and there are few members who is actively present and work with me. So uh, after the before the selection, I think everyone who is more interest with work with my topic. So I choose them only.
Okay. But I think you have to bring more clarity, right?
Okay.
So project, see, CTQ understanding, if that is not clear, and the entire project, you will be, you will be going through a lot of challenge there.
Okay, sir.
Check my project team, make sure everyone is actively present. See, I also want to make sure everyone is actively present here. But I am completely confused. How many are actively present? I only
Yes.
understand, no? Akila Karthikeyan, Manisha Rao, and Srinivasan, and then few other people who are talking. So I simply, remaining people, I just go with assumption. That's all. They are all actively participating. So you should not give room for such assumption.
Okay. Okay.
For that, you are coming out with a formula. That
Okay.
formula should always try to give you accurate information. That is called CTQ. Very good. So time to set up. Maybe you can try to improve Majumdar so that your MTech project can be successful.
Yes, sir. Yes.
Most of the time projects fail because of lack of communicating properly.
Yes, sir.
Projects, yeah. Communication, not only oral communication, your written communication is much more challenging, isn't it?
Yes, sir.
So oral communication also, okay, somehow people, by looking at your face expression, they understand what's exact message you are trying to convey. But written communication, if you make a, mess over there, then they will be completely damaged. So
Yes.
time to set up, the time it takes for an end user to set up their portal from login to final portal setup. Very good. Starting point and ending point. Roshni, you're given correctly. And the strength of alcohol, concentration of ethanol in the alcohol sample. And this has to be made more clear. You're not talking about, the amount of sample and everything. All right, so
Right,
strength
sir.
of alcohol, concentration of ethanol in the alcohol sample. Maybe you might have, some 100 ml, 200 ml sample and something like that. You can standardize. So reduction in
Oh,
ORM. Minalini Devi, where are you? You need to
Yeah,
come to help now. Yeah.
yes. So this ORM is the complaint which we usually get from the customers. through the online, otherwise Swiggy, Zomato, or Twitter, Facebook, anywhere, social medias. So a complaint from the customer on the product what we serve. So it's a QSR. So
ORM stands for?
online reputation management. So
Oh,
whatever complaint we get through the online from the
okay,
customer.
okay. Maybe. Very good. But then also see, only with the definition it works actually. Otherwise, it just ORM. Now I understand. Similarly, Akila Karthikeyan, you have written something. What is that? So to improve the lead time to delivery, what is that? Today for meals. Can you explain on that? I improve employee. Can you help us understand?
For delivery, I have to measure that how many deliveries to
Your voice is very low. Audio is very, very low. To improve the lead time to delivery. Okay. A reduction of
so I
wet
have to
waste.
extra for employees.
Oh, you have to employ extra people.
Employees to delivery.
All right. I think this exercise helped all of you understand the importance of operational definition. Yes or no?
Yes, sir.
Yes.
If the
Yes, sir.
operational definition is not clear, do you think people will be able to measure and take right action?
No, sir, they will not.
Yeah. Understanding about the baseline itself will go wrong if the definition is not correct, right? So we just proceed. So that's operational definition. Okay. Now you have a data collection plan. See your data collection plan. Nowadays, people have template, Excel template. Earlier, they used to have a check sheet, but nowadays it has become, worksheet, spreadsheet kind of thing. So you have to write down the particular CTQ, then the operation definition for it, then from where they should collect the data, the source, then how much data, the quantum should be adequate, and then who should collect the data and what frequency, right? Or when the data must be collected and how data must be collected. How means sampling technique. Would you like to collect data in a random manner or in a systematic manner, right? Say for example, attendance. Let's say every session we are taking attendance, and we can always take the attendance randomly. We can also take the attendance systematically. Now there will be a plus and minus, isn't it? So if we take the attendance randomly, let's say one day immediately after 7 o'clock, there is a risk involved. Many people would not have joined. Yes or no? 7 o'clock is the session, but then also 7:15 many people join, and the attendance is taken at 7:10. Now your sample is not representing the reality. Agreed? If we always systematically take 7:30 attendance, and people will be available exactly at 7:30, and after 7:40 you can't see them. There is another that risk is also there. So everything has got a plus and minus. This is what we call it sampling technique. You have to design a sampling technique in a way that the reality is captured. You understand? It can be a mix of random and mix of systematic and mix of a new idea also. I leave it to your intelligence. That is called sampling technique. Tell me which way of taking attendance can get us understand the reality. Can
Sir,
we
it's
can we
quite difficult. Sir, it's quite difficult because sometimes what happen, there is a network issue. So
so
someone
better
can log
better
out.
not to take attendance. So that is why we are not that's why we are not considering attendance. We are only considering your test mark. But that's not correct. At the end of the meeting, Zoom can give a report of each and everyone's attendance. Do you know that?
Maybe by communicating the participant age
How many minutes you are in the meeting?
by
By recording, you can understand that.
Yeah, that is there, right? So somehow, we need to come out with a proper, data collection technique, sampling technique, and which should take us close to the reality. See, reality is reality. But but we can't, collect too much data. So we always have some limitation. But the closer we go to the reality, it's better. And finally, X amount of data that can be collected at the same time. You have decided to collect data. Do you want to take just one sample or do you want to say take multiple samples? Already I told you the rule is more is better, right? Always when you want to take sample, take multiple sample. Never go with one. Always take two sample, maximum 25 sample, 2 to 25. So this is called a data collection plan. Ultimately, your sample, which is a subgroup of the population, must represent the characteristics of the population. You understand the definition? Why are we taking sample? Are we taking sample to understand the sample? No. We are taking sample to understand the population. What is population? Can somebody tell me what is population? Population may
Customers, sir.
mean the population of India?
No,
One for
all
Number of
types of
people who are
customers.
present in India.
Total size of lot received.
The products we produce. We want to understand the characteristics of the products we produce, isn't it? Now tell me, will you be able to see the population together in a single screen?
No.
Impossible. Very, very difficult. Already 10 years, you have sold several products. And in the years to come, you want to sell it. You will continue selling it. So your population is so big, you can't see them in a single screen. Am I right? But you still want to
Yes.
understand the quality of your population. But you still want to understand the quality of your population and you want to declare it everywhere. Our product is this much stronger. This is the specification. We want to declare it, isn't it? So for that purpose, you study only sample. You have a limited study to judge on a vast population. Am I right? This is called statistics. This is called statistics, specifically known as inferential statistics. We study the sample and judge on the population. Our exam, yellow belt exam, is also an inferential statistics, isn't it? We are not going to ask all questions. No, we're going to only ask you just 25 questions.
Okay.
The yellow belt body of knowledge is vast. We can frame several thousand questions. Yes or no?
Yeah.
But then only 25 questions will be asked. And based on your performance with respect to the 25 question, we'll simply believe that you are good with respect to the body of knowledge. That's a statistics, right? So, but your sample should represent the real characteristics of the population. You have to design your exam in a way that only, the people who actually have understood the body of knowledge should be able to crack the exam. Something like that, right? Ultimately, your sampling quality decides the accuracy. All right. So full audit, 100% inspection is always difficult and may not be accurate. Am I right? 100% inspection is not reliable. At the same time, it is difficult, time consuming, laborious, and it will be costly also. Now there is a small test to all of you. You see T-test written in my slide. Am I right?
Yes, sir.
I give you 1 minute time. You just have to count the number of T that is present in the slide. Will you be able to do it, all of you? I
Yes.
want to understand the quality of the measurement system you all have with you. You know what is the measurement system you are going to use now? Your eyes, your own eyes. Yes or no?
Yes, sir.
Your eye is going to detect the presence of a T in my slide. And if there are 120 T available, you are going to count them one by one and then put the final count in the chat box. Shall we do this exercise? Shall we do it? All of you ready? You can just,
Yes.
keep your eye ready and then you can go for it. Let's see, are we getting accurate result? We'll also check, are we getting consistent result? Once you have counted, you can type your number in the chat box. Saurabh has done. Srinivasan Mani has done. And getting accurate data is not that easy. That you will understand by seeing the chat box. Yeah. We expect our quality inspector, to check all the quality characteristics perfectly. But counting the T itself is very challenging for us. Very good. So many people have finished and all of them have shared. Now I want to ask you a few questions. All of you have counted the number of T's from the same slide. But if you look at the chat box, are the readings consistent?
No, sir.
No.
There is no consistency in the measurement, first of all. There is no consistency in the measurement. Now, how can I talk about accuracy? Whose reading I can consider to measure the accuracy?
Average.
Average. And even the average, do you think will be accurate?
No.
No.
Maybe can go little closer towards the accurate value, isn't it? Towards the true value. But if I look at your readings, what is the highest value and the lowest value?
52, I think.
Highest is
56.
57. No, 61.
61, sir.
61.
One is
And the
61,
lowest
61,
lowest is
41,
41. Huh?
41.
40.
So
40.
41 and 61.
40, 40.
40 and
Okay,
61.
40. Okay, 40 and 61. So consistency is very poor because there is a huge variation, 40 to 61, isn't it?
Sir, what is the exact
Yes.
count?
Yeah. If there is, if there is no consistency, then accuracy will not be there. Accuracy will also automatically affect it. So in order to make your reading more and more accurate, what we normally do is we take the average. Even after taking the average, we understand that the average is little away from the true value. The average is still away from the true value. Am I correct or not?
Yes, sir.
Yes, sir.
The distance by which the average of the measured value is away from the true value, that should be called as the bias. That should be called as the bias, P-B-I-A-S.
Yes.
If the bias is more than 10%, your measurement system is useless. All of you understand? If the bias
Yes.
is more than 10%, your measurement system is useless. Right? Because you are targeting an improvement of 2%, 3%, 5%. Am I right?
Yeah.
You are targeting an improvement of 3%, but your measurement system itself is having a bias of how much?
10%.
10%. That's why I said, no, your measurement system is useless. Because my project goal itself is how much improvement? All of you
90%.
understand? Yeah,
2-3%.
3%. So it depends on your project. Very rarely, a bias of 10 to 30% is acceptable. Very rarely. That too, you should have a thorough understanding of the problem, right?
Sir,
So
how
the
many T was present there? Just to know.
I'll tell you in the green belt.
That's not fair.
Okay.
It's not that.
Yeah.
I made a mistake, I'm sure.
You can put Control F. Microsoft no Office or Word will tell you correctly, very accurately. Control F. It will find the number of F. All right. So
We have to
measurement
get checkup
system.
of our eyes.
Correct. So measurement system analysis. In order to understand whether your measurement system is good or bad, you should have an understanding of bias, repeatability, reproducibility, and then gauge R&R. So the repeatability, reproducibility, and gauge R&R, they are connected. And bias is one side. Just now we spoke about bias, isn't it? What is bias? The difference between average of the reading and the true value. The difference between average of the reading or average of the observation and the true value. If there is no difference, then bias is 0. Your reading is accurate, but it's very, very rare. And the bias can be positive. If the bias is positive, what does it mean? Your readings are larger than the true value. Isn't it? If bias is positive, it means what? The measurement is more than the true value. If the measurement is lesser than the true value, then your bias is negative bias. All of you are with me?
Yes, sir.
Yes, sir.
But which is more dangerous? Bias is more dangerous. Bias means inaccuracy. And repeatability error, reproducibility error, and the combination of repeatability error and reproducibility error is known as gauge R&R. The gauge R&R is nothing but error due to inconsistency. When you look at the chat box, the readings are not matching, isn't it? Each one of you typed one value. That is called inconsistency. Which is more dangerous? Inconsistency is more dangerous or inaccuracy is more dangerous?
Both.
Inconsistent. Two is dangerous. Both are dangerous.
Both are dangerous.
All are dangerous. Definitely. So both are dangerous, but which is more dangerous? The inconsistency is more dangerous. Because if your readings are inconsistent, you can't even calculate the bias. Yes or no? Even if you calculate, you will still be uncertain. What is the exact bias? So we'll understand that one by one with a simple example. So now look at your watch and tell me what is the time right now?
8:27.
8:27. 8:27.
Now
8:27.
you all know we are talking about measurement system, so you will try to be very accurate, right? So you are not rounding off. Everyone is saying 8:27. So once you try to be perfect, you will see consistency in your reading. Can you see that, all of you? Everybody said 8:27. Yes or no?
Yes.
Now you straight away eliminated the error that can come from inconsistency. All of you, can you see that? We had a perfect reproducibility. Everybody gave the same reading. Everybody giving the same reading is known as reproducibility. Have you witnessed the reproducibility now? Some 3-4 people told me that reading, gave me the reading, but all of them matching each other. That is known as reproducibility, right? If I give you the same task multiple times, again tomorrow same time I'm asking you, tomorrow also you should give the same correct reading, isn't it? If I
Yes.
give you the same task multiple times and you should give me the same reading because it is the same task. 100 mm you are measuring 10 times. Then all 10 times your reading should be same.
It should be 100.
If all your readings are same, I'll call it you are consistent. That is also known as repeatability, your repeatability. If all of you, if you are consistent as a team, then I will call it reproducibility. If all of you are consistent as a team, then I will call it reproducibility. So if multiple people are involved in the data collection, I think most of the project, many people will be collecting data. Am I right? So individually, they must be consistent. As a team also, they should be consistent. Am I correct? Yes or no?
Yes.
Yes, sir.
They should be
Yeah.
consistent individually and they should be consistent as a
That's
team.
important.
So this is what we call it repeatability and reproducibility.
Repeatability.
If they are not consistent individually, that means they themselves don't agree to, agree to their readings. First time they give one reading, second time they give another reading. For example, one more time, if I show you the same test, same screen, T test, will you be able to give the same reading?
No, definitely not.
Maybe no.
No.
So
Already I
you
have
have
counted twice.
so you have more tendency to commit repeatability error. Same thing, you are doing it for the second time, but you clearly say you can't give the same reading. See, I'm not expecting accuracy. Please note, accuracy is my next attempt. I am only trying to get consistency first. All of you are with me so far? So one is repeatability, your ability to repeat the reading while measuring the same characteristics multiple times. That is known as your repeatability. What is reproducibility? The ability of the team or ability of the data collecting team or the ability of the multiple measurement system to give same readings while measuring the same characteristics multiple times. Clear all of you?
Yes. Yes, sir.
Okay, after doing the exercise for the consistency, after ensuring that the consistency is satisfactory, you can conduct the study for bias. I repeat the statement. After ensuring the consistency in the measurement, you can proceed to understand the bias. So now, tell me, you are wearing a watch, you are wearing a wristwatch, and that wristwatch is running 10 minutes faster. So now the time is, let us say 8:30, actually 8:32. Let me say for discussion's sake, 8:30. But your watch is 10 minutes faster. Now what will be the reading in your watch?
840.
840.
8:40. Do you think your watch is still useful to find out the time?
Sir.
Yes, if I know the difference, then it is.
Yeah. If you know the difference in advance, you mean to say if the bias is constant, then watch is useful. Am I correct?
Yes.
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 The bias should constant throughout the day. It is 10 minutes faster means I have no problem wearing the watch. I can wear it and catch the train, catch the flight and everything because I know always it is 10 minutes faster. So I will intelligently subtract 10 minutes to get the correct time. Am I correct?
Yes.
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 This is called calibration. This is called data calibration. And the calibration formula is measured value minus 10 minutes. All of you are with me?
Yes.
You can
Yes.
manage the bias. You can manage the bias and
If
you
it is
can
constant.
eliminate the bias. You can eliminate the bias and you can make your reading accurate if the bias is constant over time. Clear, all of you?
Yes, sir.
Yes, sir.
So suddenly what happens? Your watch started behaving dynamically. That means the bias is no more constant.
Then it's difficult.
How much time it is faster, no, you can't judge. It is running, in a very dynamic manner. Do you think that your watch is still helpful to find out the true time?
No, sir.
No.
No.
Definitely no. So what will you do now?
Recalibrate.
We'll reset it.
Yeah, you will take your watch to the service center, right?
Yes.
And that service engineer will change the battery, maybe change some, the worn out components. Whatever is the small issues, he will correct and then, set it right. This is called the instrument calibration. Why are we doing the calibration? So
To
as
know
to
the
eliminate the
Error.
bias. As long as the bias is constant, there is no problem. Just with some formula, that formula will automatically come to you. And that is called, data calibration. If data calibration is not possible, then we have another way to correct the bias, which is called instrument calibration. Now the watch is, running smooth. Now 3 months, no problem. Again, after 3 months, the same problem coming. Now what will you do? What will you do? Again, you will go to the service center, isn't it?
Yes.
Yes.
Again, you will change the battery. Again, some service is done. Now you understand one thing, which is known as calibration frequency. Correct?
Oh, yes.
Yes, sir.
Now you understand calibration frequency. And if the calibration frequency is too high, then you will realize, it is better to buy a new watch. Isn't
Yes.
it? Sometimes the calibration cost, if it is more than the cost of the instrument, then you might just throw it out and buy a new watch.
New.
So you should know all of this. When you are dealing with measurement system, you should know how to manage the bias. You should know how to calibrate and when to calibrate and the maintenance procedure of the instrument. And it's very important that you handle your wristwatch very carefully, isn't it? Can you just throw it here and there? No.
No.
And you have to handle it very gently. So say this is called, the maintenance of the measurement system and the usage instruction. Everything has to be followed so that the instrument can give you bias-free reading. Bias-free reading means accurate readings. All of you, do you understand what you need to do to get accurate readings from any measurement system?
Yes.
Clear?
Yes.
So we'll just go for this slide and then we will also have a short break. See here, by measurement system analysis, we are trying to ensure our data is clean and credible. See here the windshield. One side of the windshield is not at all showing the road, but the other side of the windshield is clearly showing the road even in a rainy condition. Because the wiper is working here, isn't it? This is your calibration. This is your calibration, and it is done very frequently because it's raining heavily. So same manner, you should know the calibration procedure, the calibration frequency, and the maintenance procedure and the usage instruction. Everyone who is using the measurement system should know it so that you can produce data like this and not like this. If your data is coming like this, still you are using the data, it simply means you're closing your eyes and driving your car at 100 kilometer speed. So we don't know where will you land, right? Where will you reach? So MSA ensures the data you collect is going to be accurate enough and useful for the project. Hope all of you understand. So you can see
Yes.
better and understand the process conditions better after MSA. MSA means studying about the bias, studying about the repeatability and reproducibility. Studying about the repeatability and reproducibility is commonly known as gauge R&R study. See here, there is a true value of 25.4, which is known as standard. This standard you have to measure 10 times. And you actually measured it 10 times. You see your reading? You see your reading? Now tell me, are your readings consistent or do you see some variation?
Variation.
Minor
Yes,
variations.
minor variation. Very good. It's really minor variation. And the limits, always, there will be limits for everything, there will be lower limit and upper limit. The limits are plus or minus 0.25. The variation has to be within how much? Plus or minus 0.25. But now I want to measure. So what I do is I calculate the average of the reading. The average of the 10 reading is 25.4051. And the difference of the measured, average of the measured value and the true value is how much? 0.0051. This
It's acceptable.
0.0051 is known as the bias. This 0.0051 with respect to the permissible range is how much in terms of percentage. That I am calculating. You see here 0.0051. How much is the range? Plus or minus 0.25. 0.25 this side and 0.25 that side. So totally what is your range? 0.5.
0.5.
0.0051 with respect to the 0.5 is 1%. How much is permissible? I told you. Maximum?
2 to 3.
Maximum 10% is permissible.
Oh, yeah, in bias situation,
Yeah,
yes.
but our measurement system is having a bias of only 1% with respect to
1%.
the permissible range. So the measurement system is good. Clear?
Yes, sir.
It doesn't mean that you can have error. No, I'm not saying that you have error. I'm saying that it should be less than 10%. If it is 0, that is far good. Well and good. But in this case, it is how much? In terms of percentage, it is 1%.
1%.
In terms of value, it is 0.0051. Like your watch giving extra 10 minutes. This is giving how much? Extra 0.0051 mm. Can you understand?
Yes.
Every reading, the measurement system has a tendency to add a value of how much? 0.0051. As long as this is constant, you can still make your readings accurate by using a formula. You know what is the formula? Subtract 0.0051. Correct? So this is how you
Yes.
can manage bias. So what we do is we'll take us, break here.
So just one thing. So that was an example of a positive bias, right? So 0.0051 was a positive bias, and in percentage terms, it was 1.02. Correct?
Correct.
Okay. So
If it is negative bias, then accordingly our calibration procedure will vary. Positive bias means I will subtract the value from all the readings.
yeah.
Negative bias means I have to add the value to all the readings. But you can use this method only when the bias is constant. Only when the bias is constant. So whether the bias is constant or not, that also you must study. Am I right? At different time, you should conduct the study. Morning, afternoon, evening, right? Over time, whether the bias is constant. There is one more way of studying bias over the readings. Over time, over the range of the reading. In both scenario, if the bias is constant, you don't have to worry. You can easily convert your data into accurate data. Clear? Shall we go for a coffee break now? Because you have been sitting here for more than 1.5 hours. So you can relax, right? And we will come back by 8:55. Okay? Like your bias is known as zero error. There is also a term known as resolution. Anybody here, do you know what is the meaning of resolution? Anybody here, do you know the meaning of resolution?
It's to do with clarity, sir.
Clear
Yeah,
clarity.
it is to do with clarity. Okay. Some people have very good vision, some people have poor vision, isn't it? So, true. So, resolution is otherwise known as least count. All of you, do you know what is least count?
Okay.
What is
The
least count?
smallest quantity that can be measured. So for example, on a scale, 1 millimeter can be a least count, the normal scale that we use in school. like
Very
that.
good. Very good. That is known as least count. So let us do a small exercise on least count. All of you, do you have a stopwatch with you? Do you have a stopwatch? If the least count is same with the different with the several measurement system, that means technically all the measurement systems are same, isn't it?
Least count will be 0.
Yes, sir.
Least count cannot be 0. It should be some value. That's why it's called least count. It cannot be
Okay.
0. The Roshni clearly explained, right? The law in a scale, 1 millimeter is the minimum reading you can take. So 1 millimeter is the least count. That is the resolution. Now, similarly, in your stopwatch, all of you please open your phone and then, first of all, you show the stopwatch on the camera like this. This is the stopwatch, right? Show it on the camera and then you check what is the least count. Now you look at your stopwatch and find out what is the least count.
1 millisecond.
0.01 second.
0.01
second.
0.01 second, I agree. I think one more participant said 1
1
millisecond.
millisecond.
He also wanted to mean this only, isn't it? 0.01 second only. But then the choice of the unit of measurement is wrong. Likit, you understand?
Oh,
You
sir.
can
Yes,
call
sir.
it as 0.01 second, safer side, because it is not millisecond. Because we know what is centi, what is milli, what is micro, what is nano. Am I right? What is centi? Centi
10 to the
means
power
1
of
by 10.
minus
Am I right?
10 to the power of -3.
Sorry,
1 by
centi
100.
is 1 by 100. I'm sorry. Centi is 1 by 100.
Yes, sir.
So milli is 1 by 1000.
Yes, sir.
0.01 is not 1 by 1000. 0.01 is 1 by 100. So better to call it 0.01 second. So all of you, do you have the stopwatch with the 0.01 second as the least count or the resolution?
Yes.
That means technically all of us have the same measurement system. Now I'm going to give you a task of data collection. I'm going to give all of you a task of data collection. Shall we do this? Pallama, we shall do it,
Sure,
right?
sir.
So the
Yes.
task is operational definition. Listen to my operational definition. I am going to play a song of your choice. I'm going to play a song of your choice, and you have to measure the duration of the song, right? And you can dance along with the song, you can sing along with the song, but at the same time, you should also be able to give me a reading, and that reading you must put it in the chat box, right? So, shall we go for this exercise? You know,
Yes,
you know when to start and when to stop your stopwatch.
Yeah.
The moment I start play the song, you should start the stopwatch. The moment I stop the song, you must stop the stopwatch. And the reading on the camera you can show, and then same reading you can type it in the chat box. Clear?
Yes, sir.
We are going to do this exercise. There is an error, right? If all the readings are not consistent, this is called repeatability error or reproducibility error.
Reproducibility error.
This is reproducibility error. This is reproducibility error. If I repeat the same exercise multiple times, if you don't produce the same reading, then operator wise it will be repeatability error. So the repeatability error and reproducibility error you cannot eliminate. All of you agree with me?
Yes.
If I play another song, is there, can you all give me an assurance that you all will give me the same reading?
No.
No.
You have 100 reasons, right? Why it is not same. So what we can do, yeah, we can have a standard procedure We can have an operational definition. We can ensure all of us use the same measurement system. Whatever best we can do, we can do. Thereby, we can only minimize. The reproducibility error, we can minimize. The repeatability error, we can minimize, but we cannot eliminate. That is why I told you the inconsistency is the dangerous one. Bias, we can eliminate. We know how to eliminate, isn't it? How can you eliminate bias? By calibration. Yes or no? But the bias that is resulting from the inconsistency, that you cannot eliminate. A small amount of bias or a large amount of bias, that depends on the level of inconsistency. So that is known as gauge R&R. So we will try to understand that part now. Okay. Share the file alone. Yeah. So you should be able to see my PowerPoint now. I'll put it in the slideshow mode. So the bias is understood. Now this is the definition for repeatability. Can one of you read it out louder? What is repeatability and what is repeatability error? There is a difference in the word also. When I say repeatability, that's needed. When I say repeatability error, that should be minimized, right? Anyway, can one of you read out what is repeatability?
So I'll do it. Repeatability is the consistency of a single appraiser to measure the same part multiple times with the same measurement system. It is related to the standard deviation of the measured values.
Very good. If the same person is measuring the same characteristics multiple times, if the readings are not same, that means there is inconsistency. Then it is known as repeatability error. But if the readings are same, we call it consistency. Then the readings are repeatable. But always, there will be some level of inconsistency. That is what we have witnessed right now with the song. Hari Gopal Sangha, whatever the song. So we have seen that. So the inconsistency will be there. So we have to quantify it. If you want to quantify it, you can measure the variation in your data. One way of measuring the variation is standard deviation. If there is no variation, you calculate the standard deviation. You all know there is a formula for standard deviation, right? All of you remember? You have studied. Oh, what is that? 1 minute. Yeah. Standard deviation formula is sigma equal to square root of summation of x minus x bar, the whole square divided by n minus 1. This is the formula for everything under the root. This is the formula for standard deviation. If this standard deviation is 0, that means repeatability error is 0. All of you understand what I'm speaking?
Yes, sir.
But it is very difficult to get this sigma 0. There will be some value. And then the error is equal to 6 times the sigma. The error is equal to 6 times the sigma. This is known as repeatability error. And now we move on. All of you understand the explanation here? So I just remove this. And now we move on to.
So whenever it's 6 times sigma, that's repeatability error, or
Yeah, always, when you want to measure the uncertainty or error, sigma, if you want to calculate the uncertainty using sigma, 6 times. I'll tell you why it is. Since you raised this point, I'll tell you. See here, forgot. See here, this is your data, right? Your curve. Can you see here your curve? Your curve, right?
yes, sir.
The curve represents your data. The lowest is on the left side. Can you see your lowest of your reading?
Yes, sir.
The highest value is here. And here is the average. This dotted line is the average. It is statistically found that the largest value will be at a distance away from the average, which is equal to 3 times sigma, which is equal to
3 times
3
sigma.
times sigma. Similarly, this side, how much is the distance?
3 times sigma.
Here in our data, the variation has come because of the measurement, isn't it?
Yes, sir.
Whatever variation we are seeing, it is because of the variation. Our curve has become wider because of the variation only. So, the maximum variation, which is 3 sigma on the right side, 3 sigma on the left side, and so the total is how much? 6 sigma is considered as the quantum of repeatability error. Clear?
Understood, sir.
Very good. So now with that, see, this is something to do with normal distribution, which we will be teaching you probably in the upcoming weeks. So I'm told that some of you have upgraded, you have done a good job. And because you are now very clear with the basics, now we could teach the advanced modules also, and then you will definitely be able to digest and you will be able to correlate very well and understand. So that will happen in the upcoming weeks. So normal distribution, the concept of normal distribution has to be understood so that you will be convinced about the formula 6 sigma. But anyway, I have explained it right now in a simple manner. Similarly, reproducibility. See here multiple appraiser. Appraiser number 1, appraiser number 2, appraiser number 3, etc. etc. If there are multiple appraiser, then we must go for average of the appraiser's reading. Then we must go for average of the appraiser's reading. So the difference between the average of the appraiser's reading is known as the reproducibility error, right? So now again, one more participants, can you read the definition of reproducibility here? Who can read well?
Reproducibility is the consistency of different aspirants in the measuring the same part with the same measurement system. It is related to standard deviation of the distribution of average.
Appraiser averages. Appraiser are nothing but the data collectors. The person who
Appraiser.
is collecting the data is known as appraiser. If there are multiple appraiser collecting multiple readings, then my average, I am one of the appraiser and you are other appraiser. Then my average is compared against your average. If both of us maintain the same average, we are agreeing to each other, isn't it? If my average is different and your average is different, now there is a disagreement. We call it reproducibility error. In order to quantify the reproducibility error, you must plot all the averages one by one. You must plot all the averages one by one. Oh God. Yeah. See here, I'll show you. First average, second average, third average, fourth average, so many averages, right? And this center line, whatever center line you are seeing, this is average of all the averages. What is the symbol for average of the averages? X double bar. Do you understand? Now, in this distribution also, there is maximum, there is minimum. What will be the distance between maximum and minimum? 6 times sigma. 6 times sigma. But this time, how do we calculate sigma? Using these data point. Each data point is an average. Do you understand? Each data point, first point is average of the first appraiser. Second point is average of the second appraiser. There are n appraiser, there will be n averages. You have to type all the averages in an Excel sheet, and find out the standard deviation. And you multiply this standard deviation by 6. That will be the reproducibility error. Right? So anyway, you experienced it. The reproducibility error, you experienced it. But then, the calculation part also we need to understand. So formula is finally very simple. It is 6 times just sigma. You can just follow that. And now you have repeatability error. You have reproducibility error. We are going to combine. You see here, we are combining the repeatability error and reproducibility error. When I combine them together, it is now called as precision error. It is now called as precision error. Now this precision is compared against tolerance. You know what is tolerance? The distance between upper limit and lower limit. Can you see here? Upper specification, lower specification. The range. Upper limit and lower limit, the difference is tolerance. Now precision tolerance ratio. This precision tolerance ratio is known as gauge R and R. All of you, do you understand what is gauge R and R? Come on, all of you, do you understand gauge R and R? Precision tolerance ratio. Precision is nothing but sum of repeatability error and reproducibility error. And repeatability error is the error within appraiser reading. Reproducibility error is the error between multiple appraisers reading. And so gauge R and R is calculated. But how to do the actual calculation and everything we'll discuss little later. Now gauge R and R less than 10% means measurement system is good. But gauge R and R 10 to 30% means measurement system is conditionally good. But more than 30% never accepted, unacceptable. This must be performed when your data type is continuous. Whenever your data type is continuous, you must conduct the study which is known as gauge R and R study. Gauge R and R value must be less than 10%. If your data type is attribute or discrete, then we will be conducting a similar study which will be known as attribute agreement analysis. But now what is it known as? Gauge R and R study. That's all. I think now you understand how to validate your measurement system. Your measurement system can be validated with the help of the gauge R and R value and the bias value. Clear, all of you? Gauge R and R should be less than 10%. And finally, the bias should also be less than 10%. Any questions? Just read the recap points. If you are comfortable, we can move on to the measurement of the baseline. Now you can collect data. If the gauge R and R is less than 10%, now you can collect data and calculate the baseline and close your measure phase. Clear? Shall we move? Shall we proceed?
So can you repeat it once again because my network was not working properly. Just a quick recap.
So I was saying the gauge R and R value must be less than 10%. And then you can also study about the bias. If the gauge R and R is less than 10% and your measurement system is well calibrated, that means your bias will automatically be less than 10%. Am I right? If your measurement system is properly calibrated and gauge R and R is also less than 10%, that means the bias will be less than 10%. Your measurement system will be acceptable. You can collect data. You can calculate baseline. But 10 to 30% conditionally acceptable. What is the meaning of conditionally acceptable?
Depends on situation.
Yeah, depends on the situation, but I have a specific reply for that. You can't just like that, use that for your advantage. Right? And that we will be, revealing it at the next level. because we are not just, revealing certain things at the next level just to see all of you in the program. No, not only that. You will definitely need all these basics to learn that, right? The concept of normal distribution, you should know about specification limit, control limit, and then certain, understanding will be very, very clear. So I strongly suggest all of you to upgrade this knowledge, because this is, only the intermediate level. So definitely upgrading it will be a great idea. You try to do it at the earliest. So now we are ready to collect data. We are ready to calculate baseline. We are ready to collect data and we are ready to calculate baseline. So we are proceeding to the next step, step number 6. Step number 6 is baseline performance. TPMO, yield, and other tools again in the next level, which is CP and CPK and sigma level, PP and PPK, and things like that. So measures of baseline performance: traditional yield, first pass yield, rolled throughput yield. DPMO, defects per million opportunity. CP and CPK, which are known as process capability indices. CP and CPK, right? So we'll see the first two. And this is very simple. Yield, all of you know. Imagine there are 100 students, 100 yellow belt participants, 100 of them write the exam, and 90 of them secure the pass mark. Now, what is the pass percentage?
90%.
This is known as traditional yield. This is known as traditional yield. The formula is very simple. Acceptable output divided by total input. Correct? Acceptable output divided by total input. How many wrote the exam? 100. How many are eligible for the certification? 90. So the pass percentage is 90. This is known as traditional yield. Imagine you produce 100 parts. Out of 100 parts, 90 parts have passed the quality inspection, but 10 parts are rejected. Now, what is your traditional yield?
90%.
Similarly, imagine you are doing a transaction using, the payment portal. Let's say Google Pay or Phone Pay or somewhere. And now 100 transactions you are doing. Out of 100 transactions, 90 transactions are successful. But 10 transaction payment doesn't happen. Now 10 transaction are failure. Now what is your yield now?
90%.
Will you be able to calculate this yield in your process? You should know what is success and what is failure. That's all. The definition
Yes.
for success and failure should be very clear so that you can calculate, yield, which is known as traditional yield. So that is illustrated in the form of a process. 100 transaction is the input. Out of that, 10 transaction failed. So how many transactions are successful? 90 transactions are
90.
successful. So the yield is 90 by 100,
90%.
which is traditional yield. Hope it is clear.
Yes.
All of you are using this knowingly, unknowingly, directly, indirectly. But I want to introduce one more tool, which is better than the traditional yield. It is known as first pass yield. Now here, how many of you want to pass the yellow belt exam in the first attempt?
Everyone.
All of you, right? But in case if few participants do not get through in the first attempt, they are given a second chance. Imagine 30 people out of the 90 whom we thought they have qualified. Within that 90, 30 people did not get through the exam in the first attempt. This information was not known to us while discussing in the previous slide. But now we got an information 30 people passed the exam in the second attempt. Now, what is your actual yield in the first attempt? First attempt yield is how much?
60%.
How
Ah,
much percent the people are passed?
yeah, not how much percent. How
70.
much percentage of the participants passed the
Are
exam in the first attempt? My question is different now.
Mm.
Which is important for to understand the quality of the training? The yield or traditional yield? Which is better?
yield? Yield.
Yield. But then why do you say you want to pass in the first attempt? You can pass in the second attempt then. First pass yield is better, isn't it? First pass yield is better. What is the point of appearing the exam for the second time? In the workplace also, we do a lot of rework. Do you agree?
Yes.
Yes, sir.
We do a lot of rework and don't accept or don't call them as failure. Actually, we have failed. Yes or no? So all
Yes.
the rework should be subtracted from your output first. You must learn to do that. If you do this exercise, then you realize your 90 percentage is not equal to 90%. Your 90 percentage is only equal to how much? 60%.
60%.
Your traditional yield is 90%, but for the same scenario, your first pass yield is 60%. Now you realize the enormous amount of opportunity that exists for improvement. Am I correct?
Yes.
Earlier, you thought, you are already above 90%. But the reality is how much? Only 60%. Because we subtracted all the rework. Hope it is clear to everyone.
So,
So 100 transaction, now 30 transactions delay and 10 transaction there is a failure. Now, if you believe in first pass yield, the delay also you will put under failure only. Isn't it? Delay is also a failure. Why there is a delay? Because the output has not come. So you took extra minutes to do that. So anyway, the final output looks to be 90. But if you want for this particular scenario, if you calculate traditional yield, you will get 90%. If you calculate first pass yield, what percentage you will get?
60%.
60.
60%.
When I say 90%, this is traditional yield.
Yes, sir.
The first pass yield is only 60%.
60%.
So sometimes we make wrong choice of the tool while measuring our baseline. Hope it is clear and helpful. All right. Okay. So we move on. Now the third tool, rolled throughput yield. So rolled throughput yield, when should you use? Whenever your process are linked, whenever your process are happening in sequence. I think all your process, most of the time, they'll go in sequence. Like sequence in the sense, the output of one process will become the input for the next process. Have you seen such scenarios? Yes or no? The output of one process becomes input for the next process. Under such a situation, you should go for rolled throughput yield. Now, please tell me, imagine you have three process, P1, P2, P3. P1, the first pass yield is 90%. P2, the first pass yield is 80%. And P3, the first pass yield is 70%. All of it, you understand the sequence here?
Yes.
It is like, billing process, packing, and this is dispatch, something like that. Or your machining, your welding, and your heat treatment, something like that. Or collection of application form and then checking the eligibility and then dispersal of the loan. Can you see the linkage here, all of you? In this condition, you need to calculate the throughput yield, rolled throughput yield, nothing but overall yield. When the processes are connected in sequence, and the first pass yield at every stage is like this. If you want to get the overall yield, you have to multiply the three. Multiply the first pass yield at each stage. 90%, 80%, 70%. What will be the overall yield? Overall yield will be 50%. How is this coming? 80 percentage of 90% is only 72%. 70 percentage of the 72 percentage is only 50%. 50% means it is like getting a head or a tail. Your success rate is how much? 50%, which is very poor. You should not settle by looking at, the first pass yield at every stage, 90, 80, 70, looks good. But what is your overall? Overall is only 50%. Almost half of what you produce is unacceptable. This is the rolled throughput yield. All of you understand?
Yes,
Will you
sir.
be able to use it? Will you be able to use it?
Yes, sir.
In
Yes,
order
sir.
to calculate the rolled throughput yield, you must have the first pass yield at every stage. Now tell me, there are two stages. There are two stages. There are two stages. First stage, imagine there is an yield of 85%.
Hmm.
First stage, there is an yield of 85%. And in the second stage, there is an yield of, let me say, 65%. Now, what will be your RTY or overall yield? Tell me, do the max and tell me. First stage 85%, second stage is 65%. What is the
55,
RTY?
55.25%.
65. Let me also check.
55. 55.25.
0.85 multiplied by 0.65. So 55.25%. This is the overall yield. Bottleneck is the lowest is the bottleneck. Lowest is the bottleneck. So that should be given the priority or importance to improve first. All right. Now let's understand, the DPMO with one more example. So imagine I am asking all of you to fill up a Google form. I'm asking all of you to fill up a Google form. That Google form contains 10 items. I mean 10 questions. Now, maximum how many questions one can answer wrongly? If there are 10
10
questions,
times.
if there are 10 questions, maximum one can answer wrongly is 10
10
questions.
times.
So the opportunities for defect is 10. Can you see that, all of you? All of you understand why the opportunity for defect is 10?
Yes.
Because
Yes, sir.
you are filling up an application form, your name, your photo, your date of birth, so many things you are giving that will come in the certificate. Suppose you give your name wrongly, what will happen? Your certificate will have a wrong name. If your photo is blur, then it will appear in the certificate the same manner. So 10 items at the maximum, one can make mistake in all the 10. That is known as defect opportunity. All of you agree?
Agree, sir.
Defect opportunity is
Yes,
10.
sir.
So imagine 15 people participate in the survey. So what will be the total opportunity? 150.
150.
Now the survey is completed. Now you are verifying the details. Now 22 details are submitted incorrectly.
Hmm.
22 details are submitted incorrectly. Now,
Hmm.
what is defect per opportunity? Defects divided by total opportunity, which is 22 divided by 150.
150.
How much it is? 0.146.
0.146.
DPO is 0.146. So DPMO will be, you move this decimal by 6 places. 1 lakh
Yes.
46,000. You open my sigma level calculator. I gave the sigma level calculator. Am I right? I
Yes.
gave that Excel file, yes or no?
Yes, sir.
Yes.
Yes.
You open that file, substitute 1,46,000, then sigma level will be revealed to you. So there are two methods, in fact, sorry, three methods by which you understood the baseline measurement. One is traditional yield, the other one is first pass yield. There is one more rolled throughput yield, which is actually reflecting the reality. Traditional yield or first pass yield? First pass yield.
First pass yield.
And if there are too many processes that are going in sequence, happening in sequence, then you must consider rolled throughput yield,
Roll throughput
which is nothing
yield.
but overall yield. The final output divided by initial input. Final output divided by initial input, right? That can be calculated by multiplying all the things. Similarly, DPMO can be used as a baseline. All of you agree? For a
Agree, sir.
survey, just now we understood how to calculate DPMO. Correct?
Yes, sir.
For a physical product, the very first day we did one DPMO exercise.
Yes,
As
sir.
long as you can define the defect, you can calculate DPMO. So these are the methods by which baseline can be measured. So this completes our measure phase. If there are any questions, you can ask. So any questions, please feel free to ask. Otherwise, we must switch our thinking from measure to analyze. So measure phase is over. So I'm showing you the thank you slide, just to let you know that measure is over. Okay. So any question on measure? Anybody would like to ask anything? Feel free. If you have done any project, or if you are having a similar scenario in your workplace, you want to
Sir,
ask.
sir, I have one question that in the previous slide, there was, in the DPMO, there was one calculation D by BC into million, right? So what is that D by BC?
Okay, I will show that. So
This is the opportunity.
we're talking about this slide, right?
Yes, the 7th point.
Okay. Who is that? Someone should be muted. Srinivasan Mani. Srinivasan Mani, mute yourself. I'm not able to mute you. What happened? Okay. I think your question is correct.
Yeah, in the symbol formula, the last line, the D by BC.
Yeah. So A is understood, B is understood, AB is understood.
Yes.
C by AB is understood, right?
Yes.
Correct. Oh, okay. What is D? Correct. This is something wrong. You found out correctly. I'm sorry for that. This C by AB, we are multiplying by 10 power 6 to get this. That's all. Very simple. This is wrong formula. You're right. There is no D there. And I think some typo error. Correct.
Okay.
Perfect.
Thank you so much.
I'll also correct that. I'll correct that. Good.
Sir, when you were explaining one example, right, 65% and 45%, you mentioned that you mentioned something about bottleneck. What exactly is a bottleneck?
Yeah. So bottleneck means the area where the maximum loss is happening. Right? Area where the maximum loss is happening. So we call it bottleneck. In that particular example, the yield was very low in that particular process, 70%. So 70% is the bottleneck. So your immediate focus should be on the bottleneck process. Because if you have process connected in sequence, your overall yield cannot be more than the bottleneck. Your overall yield cannot be more than bottleneck. So if you are looking at a value, a better value, first you should focus on improving the bottleneck. Understand? Instead of improving the bottleneck, if you make the improvement in the other stages, your effort will not reflect in the result. You might be improving, but then the result will still be, almost same only. Because the bottleneck is still at a poor level. So you should first improve the bottleneck, then move on to the next bottleneck, then move on to the next bottleneck. And this is called prioritization. Prioritizing your efforts. That's also important. So we are done with the measure. All of you, are you happy? You understood the measure phase?
Yes, sir.
Okay. But then deep diving has to happen. That probably at the next level, you should definitely be able to do it. Since you have the thorough basics, yes, you can understand the advanced modules very nicely. Okay. So now we have got 15 minutes. So I should take you through the next phase. The next phase is analyze. Let me get the slides. That Govinda song is still pending, balance song that is playing. Analyze is module 3. Confirm? Can you see my slide now? Introduction to analyze.
Yes, sir.
Yes, sir. Yes, sir. We can see.
Very good. Okay. So toll gate review, analyze steps, deliverables, and the tools in the analyze space. The objective of analyze space is to identify and validate the root cause. So first question, the end of the analyze phase, the toll gate review meeting, the important question will be, what is the source of variation? That is root cause. They're asking about root cause. What is the source of waste? What is the source of variation? What is the source of risk? Have you identified the potential X and the critical ones? Have you identified the potential X and the critical ones? We'll clearly understand the difference between potential factor and critical factor. Have you statistically validated the root cause? Have you statistically validated the root cause? Has the validated factor sufficient? And finally, have you identified any new risk? All of you, do you understand the importance of each question? Do you think each question is important?
Yes.
Yes, sir.
Now, can one of you tell me what is the meaning of this question? Have you statistically validated the root cause? What is it? What are they asking? Come again, please.
Yeah, the proper evaluation of the root cause.
So people are, out of discussion, people are telling that this is root cause. But do you have any experimental evidence? That is a question here. Please understand. See, in a meeting, people can tell, anything that they want to tell. It's a brainstorming. Just because people are telling, do you think that's the exact root cause? May or may not be. So sometimes you may have to experimentally verify and be sure that you're taking the right action. So that is the significance of this question. Now, this question, what is the meaning? What is the meaning of this? The meaning is how many root causes are pulling your result down. What is the meaning? How many root causes are pulling your result down? Is it just one root cause or are there many root causes? All of you understand? That is called sufficiency. Now, finally, because of the changes you are making, are there any new problem you are inviting? That is this question. By solving a problem, most of the time we invite two other new problem. So that should not happen, right? So the risk should be under control. Hope all of you understand the meaning of every question. Now let us understand the analyze phase step by step. The first step, listing possible X factor. Then immediate next step, identify potentially critical factor and validate the critical factor. So let me add one word here. Identify and validate potentially critical factor. You have to read it like this. Identify and validate potentially critical factor. I'll tell you what is potential factor and what is critical factor, everything. Then we move on. Verify sufficiency of the factor. In order to better understand these steps, let us consider a scenario. Let us consider a scenario. Imagine there is a party. What is that? There is a party, wedding party. And wedding party, there are, let's say, several guests. Let's say 100 guests are there, 100 guests. And now, in that wedding party, a lot of valuables are there, including 100 sovereigns of gold. What is the valuable we are talking about? 100 sovereigns of gold. Let's assume this is stolen. The 100 sovereigns of gold is stolen by someone. Now you have to investigate and find out the criminal, right? And you have to find out the person who has stolen this. Now tell me, how will you investigate? Come on, all of you, just imagine if you are in such a scenario, you have to investigate, right? And what is your loss now? All of you are sleeping. Now it is almost your bedtime, I know. But still, I expect aggressive discussion. Yeah.
Checking
100
the
sovereigns of
bags.
gold. Yes, Promit. Come on.
Yeah, checking the bags and maybe, frisking as well.
Okay. Very good. I agree with Promit. What else? Others? Tell me, it may be helpful. This discussion may be helpful sometime. No? If we really have to face such a situation, we can follow all this advice. Brainstorming is happening right now. Okay, Promit, the idea noted. Yes, we have to check all the bags, frisking. Yes, we will do it. Then?
Seal the entire area.
Very good. Fantastic. Suajit, right? Who said this?
Minalini.
Okay. Why your name is not showing me? I don't know. Okay. So fantastic point. That means she want to secure the place, isn't it?
Yes. Yeah.
That is this particular step. She don't want to allow anyone to escape from the place. Am I correct?
Yes, sir.
Nobody should escape from the place. This is what you should do. In your equation y equal to f of x, can you list down all the x? X1, x2, all the x. Don't leave anything. Do you understand, all of you?
Yes,
This
sir.
is known as possible X factor. The moment I secure the place, I am very, very sure that the criminal is inside that secured place. Am I right?
Yes, sir.
You are collecting the information of all those who attended the program. That list is available. That means the criminal is in that list only. Correct or not? Now my question is, will you be able to create such a list for your project? Why my Y has gone down? Definitely that culprit should be in your list. Am I right? All of you understand?
Yes, sir.
Yes.
For that purpose, there are certain tools. I will show you. There are certain tools which you can think of using, probably we'll be discussing tomorrow only. Then ultimately our goal is finding out the criminal. And see here the tools. Look at the tools. Tools that can help you to list out the possible X factor. What are the tools?
Brainstorming.
Brainstorming, Y
Y
analysis, and then
cause and
cause and
effect.
effect analysis. Very good. These tools can certainly help you. All right. And then after securing the place, what will you do? You will also inform the police. Am I right?
Yes, sir.
Yes.
Either you will act as a police, or if the situation is difficult, you will call the police. Similarly, you can act as an expert, or if the situation is difficult, you can invite a subject matter expert for the next stage. All of you understand? Right?
Yes, sir.
And now the police has come inside the hall. Tell me what they will be doing.
They will ask so many questions.
YY analysis, right? They will ask us
Yes.
so many questions. They'll ask so many questions and they will refer to the CCTV footage, existing information, right? Existing information, and they will try to understand how many people were given the access to that particular room where you kept that valuables. Yes or no?
Yes.
Yes.
And then they will be interacting with the people. What are they doing? They know 100 people investigating each one in the hall is a difficult job, very laborious.
The
They have to
collecting
spend,
data.
yeah, they will try to figure out the no, the suspect cases. Out of the 100, they will try to figure out 10 or 15, the most doubtful cases. The most doubtful cases are known as potentially critical factor. Am I right?
Yes, sir.
Right, sir. Right, sir.
That's why I wanted to add here potentially critical factor. That is your next step. If you simply investigate all 100 factor, then you won't be efficient. You will be wasting a lot of time, lot of effort, and of course lot of money. And sometimes you end up not deducting anything also. So to avoid that, we segregate the potentially critical factor. For that, we have tools like impact control matrix, or sometimes we use cause and effect matrix. All of these tools will help you to figure out the potentially critical factor. Now, police department have understood. They identified 10 people out of the entire group. From the wedding hall, they identified 10 people. Now, these 10 people were taken to the police station. Were taken to the police station for the next level of investigation. You know how the investigation will be at the next level, isn't it? Right? So far it was going very smoothly. But after reaching the station, it will be very intensive, right? It can go to any extent. So same manner, you should also become very vigilant, right? And you should not give any room, for assumptions. Don't go with assumption. Clear, all of you? Up to this is okay. You have taken opinion. But after listings, after separating the potential factor, you must go with experimental findings. Please understand what I'm writing. You should only believe experimental findings, no more assumption. All of you are with me?
Yes,
sir.
No more assumption.
Yes, sir.
Experimental findings. That is known as hypothesis testing. That is known as hypothesis testing. People can tell, hey, this is the root cause. This is the potential root cause. Yes, very good. You note all of that. But then one by one, you experimentally verify. And once some of the factor will get validated. Validated means data will also confirm the statement. Data will also confirm the statement. Now you have two team members. And people are telling that one of the team member is working very hard and producing, good, better results. So he should be given more increment. Now really they're an appraisal time. There are two team member in your team, and people are telling that this person should be given more increment because his results are much, much better than the average result. The other person's result is very average. People's opinion is this. Now you can either simply believe and then, proceed with the decision. Another thing is you can verify the information with the data. If you verify the information with the data, that is known as what? Hypothesis testing. Clear, all of you?
Yes.
And in hypothesis testing, we will be checking the significance, not the difference. Please understand. Difference will always be there. But significant difference will be there only if there is a real difference. We will do the experimental verification and then we'll take a decision. Now all the validated factors are now known as critical factors. Validated factors are known as critical factors. When I call a factor as a critical factor, it simply means that is the root cause. It means what? The root cause. Out of the 10 potentially critical factor, after validation, I realize there are 3 factors are critical now. That means in the current situation, 3 factors are really troubling you. Now you need to take action for each of the factor. Now if there are 3 factors, which is the major contributing factor? Which is the factor contributing majorly? Now 3 people combinedly, they have taken that 100 sovereigns. Now you understand, out of the 3, one fellow acted as the gang leader. He is the major contributor, isn't it? Now that fellow has retained half of your item. I mean, half of the valuables. 50 sovereign is with that fellow. Okay. Remaining 2 people, 25 sovereign each. The total is tallying to 100% now. You lost 100 sovereign. Now the police is able to recover 100 sovereign. That means the investigation is successful. So you will also understand whether your investigation is successful or not by, 1 minute, by using a study known as regression analysis. Tomorrow I'll talk about it. You know what is that? Regression analysis. Regression analysis will clearly tell you how much you can recover. You know very clearly about the loss, isn't it? You lost 100 sovereign. You lost your yield by 20%. Can you recover all 20%? by making these 3 improvement? Or how much improvement you are going to achieve? That will be understood by using the tool regression analysis.
Yes, sir.
Is it not amazing if you know all these things in advance?
Yes, sir.
Yes, sir.
So you can confidently take action. All
Okay, sir.
right. So here are the tool recommendation. You see, brainstorming, wave analysis, cause and effect diagram. What is the purpose? To find out?
Regression.
What is the purpose?
Regression.
To find out the X factors.
Yeah. Very good. That is, we call it as, can you see my screen? We call it as possible factors. Oh God, I think something changed. Okay. I'll go to the same slide. Yeah, here. So these tools are helping you to find out the possible X factor. And this particular tool will help you to find out the potentially critical factor. Potentially critical factor. And these tools will validate. And these tools will talk about the sufficiency. Now, do you know the meaning of sufficiency? Right? Whether
Yes, sir.
you are going to recover the loss by 100% or you are going to recover the loss by 80%. The important tool is R square. The important tool is R square. All right. So this is what is in the analysis space. The objective is to identify and validate the root cause. For that purpose, you must list all possible X using brainstorming, fishbone diagram, Y-way analysis. And then we should narrow down our focus to potentially critical factor. Either you go for a Pareto analysis, or you go for an impact control matrix, or you go for a cause and effect matrix, some way of prioritization, logical way of prioritization. Once you do that, then you formulate hypothesis, experimental validation, and validate the root cause. Then you perform the regression analysis to understand what percentage of the loss you are going to address now. If you are happy with the percentage of loss which you are going to address, then proceed to the improve phase. If you are not happy, then what should you do? You should go back. Go back, find out where you missed. Is that your brainstorming was not proper? Or cause and effect analysis was not proper? Where your people failed? You include that factor and then come back. Again, look at your regression. Your regression will now be closer to 100%. If your regression is closer to 100%, it is good to proceed to the next phase. You know what is the next phase? Improve. Otherwise, even after improving, even after taking action, even after implementing solution, you may still see the problem continuing. That should not be the case. So it is always a good idea to look at, what? R square. To look at R square. So which is actually a tool under regression analysis. All right. So that's it for the day. And tomorrow we will be spending enough time on analyze phase, the rest of the analyze phase, and then we will try to understand the improve and control with the help of a case study. And then we will have a short feedback session. And then we'll be winding up tomorrow as far as the yellow belt modules are concerned. All right.
Thank you,
So those of you who are planning for the upgradation, please check whether that is possible. You can check with your concerned coordinator. Thank you so much for
Thank you,
joining
sir.
Thank you
today.
so
We'll be
much,
meeting
sir.
tomorrow.
Thank you.